All right, guys. Thank you for watching my YouTube channel. This is another video. This is the Backyard Discovery solar carport install. This is going to be the electrical side. I want to show everybody what I'm using here, and then show you the differences. And then I want to flip back because there's been some questions that I've gotten a little bit more on the CCA and the TAP, which would be your rapid shutdown device that I put in this, and it's covered in some prior videos, but I figured I would just jump back to it real quick, just to give everybody an idea exactly of what maybe I misexplained it a little bit. So I figured I'd go a little bit more in depth with it on again. But anyway, let's go ahead and get started. This is the breaker panel that's being used for the new solar install. What this is just a simple square D. It's just a simple square D breaker panel, but it's got a few key differences, and I'm going to go over some of them differences for you here real quick. Let me see if I can pull up right here. Okay, so you can see right here where it says square D meter main, combination service entrance, solar ready device. And that's what I'm going to show you is what it means when it says solar ready. So let's go ahead and jump in this here. So I've already pre-built this box. It's getting put on tomorrow. They're going to come shut the power off. They're going to let me put it on. And then they're coming back Saturday morning to hook the lines back up and complete this install. Anyway, so you come up here. You're going to start out with a mast. Your mast comes all the way down, goes into its junction point right here into the box. When you buy these boxes, they do not come with these fittings here. So you've got to buy the correct fitting for your whatever box you're going to choose to use. Just make sure whatever box you're using, it says it's ready for that specific box. And all it is literally a mast holder. It uses a 2-inch PVC or this Candex conduit right here. You glue on your PVC adapter here, you screw it on here, and that's pretty much it. And then you glue on your mast wire top right here, and that's the completion of that mast. So let's go over some of the key differences of what this box actually entails. So if you look right here, you can see right here is where your access point for your wires come down. Your wires come down, and they come down and they hook into here. Here's your neutral line. Here's your first leg. Here's your second leg of your 120s. Yeah, 120s coming in. And they hook up to this. This here back feeds from the main. Right up here, it supplies power when you add the meter to power this leg here. So you get these powered, and then it jumps to this leg with the meter, which in turn comes around, it feeds back down through here into your 200 amp breaker. Now, on a normal breaker system, this is exactly what you're going to see. You're going to see this 2-point design. I mean, it's not going to be exactly like this. These ones are built a lot differently, with a lot thicker of metal. I'm assuming that must have something to do with solar, or the idea of solar being that you got different amps coming in. So it's just built it's built a lot stronger. But you come over here, you can see right here. See, these are where these hook in. Now, on a normal breaker, this is where your wires generally hook in. So you would have your leg that would come here, your leg that would come here, and then there's usually a neutral over here. And then you usually got, similar to this, like right here, you have a ground. Here would be your neutral bus bar. So right here's your neutrals. This is going to be your ground right here. And right here's all your grounds. You can see where it feeds in from here to the other side over here to give you your neutral on this side over here. Anyway, what makes these different, these boxes, is you got these legs right here. So this one, and this one. Now, as you've noticed, I've already got a breaker installed for my application. It's a 60 amp breaker, and that's what my inverter calls for. It's 11.5 kW, and it's going to use, what is it? I believe it is 4 or 6 gauge wire. I don't remember, but I know I sized the breaker appropriately. I'll cover that in another video of what exactly the wire is that it uses, but that's what it calls for. It calls for a 60 amp breaker for my particular system. But right here, here's your solar inputs. So these are your AC side. Now, if you've looked at my past videos, you'll see where I've covered what's at the house already, the AC disconnects, the DC disconnects. Well, from that AC disconnect, you're going to have your inverter that would come in all the way around inside the AC disconnect to that switch I showed on my house. And then you're going to go from the AC disconnect, the shutoff point, you're going to come to these legs here. So one of your lines from that inverter coming out would be, one of them would come here, one of the 120s, another 120, and here's your neutral. It's going to come off. All this is coming off the inverter side of the house. So when I hook up the inverter, I'll cover this a little bit more in depth. But I just really wanted to go over the key differences of what a solar-ready box actually is. And this is what makes a solar box a solar box. This is what makes it ready for solar installations. It's these additional legs. On a normal box, you're not going to have these. So you can see how this one's set up. Let me see if I can put it together real quick, show you guys exactly how all this is set up. So this slides in here just like this. You can see the breaker's already ready. This has got to be labeled as a solar shutoff. You got this panel right here. It's just another simple access panel. It goes right there. There's a little screw that holds it on here. Just like that right there. And then you got another one up here. Here's your meter section. And it goes just like that. And there's two screws that I've got sitting here. It screws here and here. And then there's two other screws sitting there that screw here and here. To give you an idea, I'll show you what these boxes look like here. See, here's all your like wiring diagrams, I guess. I mean, they might be useful to somebody who's never done this. I've done this stuff before, so it's, you know, hooking up these boxes is just another day in my neighborhood. But that gives you a brief overview real fast of how these boxes work and what the key differences are on them. Another thing I'm going to go over is in my house I have a Sense system, and it tells me kind of what's going on with the electricity and as far as what's being used, what's not being used. And it gives me a baseline price of what I should expect from my local utility company come bill time. But this here goes to that system. It's a Sense system. I opted for the Sense with solar. And these will hook up to those two legs that I was telling you right down here, the Solar Ready, that hooks up to the two legs of that. And what that's going to do is that's going to tell my Sense, it'll pair with that Sense, and it's going to tell me exactly how much energy production is coming into this box via Sense. However, the system that I'm getting ready to go back over with you guys right now, let me find it real quick here. Let's see here. So this system right here is going to do all of that anyway. It's that Tigo system, or Tigo system that I was referring to. Let me see if I can find another line here. Okay, so we're going to go back over this again. So these are the parts of the Tigo system here, okay? So what this is your communications module. And what it does, it's called the Cloud Connect module. And what it does is it communicates with this. This is called your tap right here. So if anybody can, see exactly what it is, this is called a tap. This unit here communicates with this unit up at the solar panel array, and it lets everything know that it can work or whether it needs to be shut down. So this is part of an advanced rapid shutdown system, and what this does is this little breaker panel right here, and it's really not even a breaker panel per se. What it does is it takes 120 power in, and then it sends 24 volts out the opposite side. So that's all it is. So like right here, so you can see your advanced, your adjustments. This is so you can adjust that power in and out. So if you get it from the factory and it's only producing 18 volts, you turn this to the plus, and you're going to until you get your 24 volt what you need, and you test that via just a simple multi-tool tester to find out what your volts are and get your volts correct. But this unit right here, this communicates, like I said, again with the tap. It's got an antenna right here. It's a Wi-Fi antenna, and that does everything on your phone. You can shut this system down from your phone if you want to. It'll give you all the advancements of what your system's actually doing when it's up and running. So you can look on your phone, you can see if a panel's not working correctly, you can see if a panel's got issues, but it's also got a fire protection in it too. And what it'll do is if it senses something wrong with the panel, it'll just shut that panel down. But I just wanted to go over a little bit more in depth with this system right here, because like I said, there was a little bit of confusion. I had a couple questions on it, so I figured I'd answer it in a video and get it to where hopefully I made it a little bit more understandable than what I did in the past. Now, I did get the RS485 cable. Just so everybody knows, if you're running the cable in the array inside of the conduit that however many leads you're going to come out of your array actually have. If you're running your cable inside of that conduit with your main leads coming off your panels, code says you have to have 600 volt ratings on the RS485. The only ones that I can find that have that 600 volt rating is a Belden RS485 cable. Now, if you're running it separately, now that changes the platform a little bit. Now you just need simple RS485 shielded cable through conduit, separate from everything else, and that solves your problem. If you're looking for a cheaper route, that's the route to go. I didn't account for conduit with that cable before I had bought in this box, so I had to run it separately. So I ended up getting just a standard shielded RS485 cable that plugs into these fittings right here, and then it comes back, and it'll come back through, and it'll come back up through here, and then it eventually makes its way into these, let me see if I can find it right here, right into this slot right here. That's where those cables are going to end up going. And then over here, here's your power that's going to come off of this thing right here over to here for the powering of this device here, and then you run your 120 into this device here, which in turn powers this, and then it in turn powers this. But with that being said, anybody has any more questions, like I said, I'm always willing to answer them via video. I try getting to them if they're left in a post, but generally when it comes to questions, I'll answer them in a video. If you guys like my channel, please like and subscribe. It really does help the channel. It helps get my gets the search results for me up a little bit higher, so it can help other people see how to do these systems here instead of having to search 500 different places, 500 different videos. But with that being said, I hope everybody likes my videos, and I hope everybody has a great day, and thank you for watching. Bye.